A mouse can be directly connected to an Arduino. Can you imagine? Here is a mouse with a USB connector, a breakout cable that I made by cutting a USB extension cord, and the Arduino itself. In this video I show how a PS2 mouse works and also an easy way how to use it in your Arduino project. But actually this works only with older mice that still support the legacy PS2 protocol. The newer ones only understand USB and must thus be interfaced with an USB shield. Due to its complexity and the fact that it has to operate at frequencies of around 6 MHz, it is impossible to process USB protocol on the Arduino itself. But if you still have an antique mouse with a PS2 connector or an old USB mouse, you are lucky. To visualize what the mouse is actually doing, I have connected two 5V LEDs as pull-up resistors between plus 5V and its data and clock lines. I've also hooked up my USB oscilloscope so we can get a closer look at what's going on. PS2 is basically a synchronous UART protocol. This means that it consists of two separate signals, data and clock. So the device sends a clock signal of about 10 kHz and a data signal with a start bit, 8 data bits, parity and a stop bit. The receiver samples these on each falling edge of the clock line. As a UART protocol, PS2 can easily be received through the Arduino's internal serial port. If this is configured for synchronous mode, the clock goes to pin 4 and the data to the usual RX pin. After setting some bits in one of the Atmega's UART control registers, you can call any of the Arduino framework serial read functions to retrieve the data. But first we need to get the mouse to send some data at all. When power is applied, the mouse sends 2 bytes, AA hex and 0, indicating that it's alive. Did you see the 2 LEDs flashing when I plugged it in? This is useful for a quick check to see if it's actually a PS2 mouse that we can use for this purpose. Modern USB-only mice like this wireless mouse here don't show this behavior. But even with a suitable mouse, nothing happens when I move it. And the light doesn't light up either. So the next step is to activate the mouse by sending it the enable data reporting command, which is a single byte with the value F4. But hang on! How can we send any command to the mouse if it has only one bidirectional data line that is already connected to the receive pin? To solve that, the receive pin must temporarily take the role of the transmit pin. So we need to disable the Arduino's UART to misuse the RX pin as an output pin and set its level by software. This is done in an interrupt routine that shifts the bits out of the receive pin, triggered by the external clock on pin 4. Once activated by the Arduino, the mouse sends clock and data when it's moved or a button is pressed. This comes in groups of 3 bytes that contain information about which button is pressed and how far the mouse has been moved in X and Y direction since the last message was sent. However, with this so-called stream mode, the frames are indistinguishable from each other because they have no headers to identify them. So you would also have to measure the times between the sequences to match them correctly. This is however difficult to code and the sequences come in at a high rate. All in all, this would consume a lot of the Arduino's processing power and slow it down. As a solution, we can put the mouse into remote mode by sending it an F0 before activating it. When in remote mode, the mouse only sends data when it's requested by the read data command. This time we see 5 packets where the first one is the read command itself, then comes its acknowledge, and the following 3 contain the pressed buttons and the X and Y movement. This method is more deterministic and therefore easier to handle by software. It is sufficient to call the read data function every 100 milliseconds. This way the mouse is still responsive and the Arduino has enough time for its main task. Sending a special sequence of 6 bytes to the mouse during initialization does also include the wheel in the response if the mouse has one. It will then return an additional byte that tells us how far the wheel has been turned. Do you have an idea for a project where a mouse would make sense? Write a comment. Whatever your project, PCBWay may be the right partner for you. All you need to do is upload the Gerber files to the website, submit the order, and a few days later you will receive these high quality PCBs. And they only cost $5. Assembling them is fun and super easy. Here I'm soldering a tiny chip about the size of a grain of rice. And the result looks pretty cool, doesn't it? And PCBWay does not just make PCBs. They also offer CNC machining, sheet metal fabrication, 3D printing and injection molding. So check them out. To make it easy for you, I wrote a small library for Arduino UNO and Nano boards. Here's how to use it. Connect the mouse to the Arduino like shown here. The 10K resistor is needed to be able to upload the sketch while the mouse is connected to the Arduino. Once development is finished, it can be removed. When using a mouse with USB connector, the colors of the wires give a good orientation. When done with connecting, download and copy the files to your project location and include the header file into your project. There we call mouse init in the setup function to initialize the mouse. And in the main loop, mouse update has to be called repeatedly to retrieve the movement data. Each time something happens, the onMouse function is called with its parameters containing the current data. There are also the two additional functions onMouse ready and onMouse disconnected. I think these are pretty self-explanatory. And that's it. Here's what the example does. The mouse buttons change the color of an RGB LED, the scroll wheel changes its brightness. And the brightness of the four surrounding LEDs is changed by the X and Y movements. And now is a perfect moment to click this button below to get notified whenever I publish a new video. Also hit this one if you like it. I always appreciate your ideas and thoughts in the comments, as well as you becoming a patron on Patreon. Get ad-free preview videos and other goodies there. See you in the next one.